is going to be the OHI's Introduction to Open Data Science. And what we're going to do in the next couple of lessons is learn all of the tools that we use for the Ocean Health Index, and sort of in not only learning them independently, but learning how we use them as a workflow. So we're going to teach you guys several tools kind of at the same time, and then practice them all together rather than learning them independently and practicing them separately. So it's going to be kind of a lot at the beginning, and we'll keep practicing it through all the lessons and then also in all the tasks that we do on our own. So we're going to focus on R, RStudio, Git, and GitHub, as we described in our recent Nature publication. And I think, yeah, one of the things I always like to say is that this is going to be super fun. And we think that all these tools are really empowering and really fun to learn. So we hope that that sort of comes through in this stuff as well. So, you know, right now we're sitting here in this room together, but even if you're watching this video on your own computer, you should be set up in a place where you can be typing on your own computer while you watch this or see the screen here now, because this is kind of a hands-on learning session. It's not a lecture at all. What I like to say too here is what to expect. So we're going to expose you to a lot of great tools and give you confidence using them. We're going to go through a lot, and it's less important that you remember it all, but it's important that you have like experience with it and know it exists and have confidence that you can either do it or kind of know that it would be possible to learn to do somewhere. So we're going to be talking about specifically today how to think about data and how to think about specifically tidy data, which we'll get into, how to increase reproducibility in your science and research, how to collaborate more easily with others. And the most important person you're going to be collaborating with is yourself, because there's a lot of bookkeeping that you do every day to try to help you remember things later. And we're going to be using GitHub and systems that are built in to take away some of the bookkeeping you're doing on your own so that you later will remember what you've done now. And then another big thing about this is that learning how to code and all these tools, it's social now. It's not something that you do on your own if you don't want to. There's a whole community online, and there's meetups that you can have locally that really make this like a fun thing to learn. It's not something like the way I learned, which was by myself in a total panic. It's like, it can be fun. It can be done with friends. It can be done in a lot of different ways. So I think that's been a huge part for me and why I am so excited about all this stuff. Another thing too is everyone here is coming from a different place. So everyone has different experiences. Everybody has different expectations. But I think everybody's going to learn something new, no matter where you're coming from. And the pace at which tools are being built, both on the coding side and on the collaborative side, are really exciting. And so I always learn something new from like the questions that you guys ask. And I think like other people learn just by teaching as well. These are funny book covers that I really like, but a way to learn how to program is to see an existing example that works and change stuff and see what happens. That's the way I learn most of the things I do. And then another one is to, when you get an error message, is to Google it, and we'll talk about exactly how to do that. Just to give us a whole overview here, we're going to be working with tidy data, and the idea that no matter what kind of data you're working with or what kind of scientific research questions or what kind of project you're working on, this is a workflow that you're going to follow. So somehow you're going to have to get whatever data you're working with onto your computer and into R in our case. So that's a whole step. You're going to have to tidy it so that it has a structured format that then you can work with it in this kind of looping cycle of transforming it, visualizing it, and modeling it in order to understand what's going on. And then you'll ultimately be communicating something at the end of your analysis. But something I like to say too is that the communication part is actually going on throughout as you're explaining to yourself potentially or to anyone else what is going on and sort of the decisions that are made. So communication is a big part of this, and also collaboration is a big part of this throughout. And using RStudio and GitHub the way we do, communication and collaboration become overarching theme here. Specifically, when we look at these sort of steps, there's actually specific R packages that help you achieve all of these steps as we go along. So we'll be using the tidyr package to tidy some of the data. We're going to be using dplyr to transform some of the data, visualizing with ggplot, and communicating with R Markdown. When we really get into R programming, we're going to start at the visualization process. So we're not going to start here where you might expect, but we're going to start with getting your hands on data and visualizing it and kind of seeing how programming is visually, like what happens as you program. And then we'll sort of work our way back out towards importing. When we get into learning R, we're going to be using the Gapminder data, which is a data set that we're going to use throughout the book. And one of the things I really want everyone to take away from is that it's important to think about data separately from your own research context. So we're not going to be using data that you might be using in your own projects, but it's important to sort of distinguish the data transformation questions from your scientific research questions and learn through metaphor this other data. This Gapminder data set is actually a really rich data set that represents the health and wealth of nations. And it was pioneered by this awesome statistician called Hans Rosling that he gave this TED Talk, which is really a super engaging talk about statistics and visualization. But it's a really rich data set where there's every country in the world through time on a bunch of different indicators about wealth and health. So there's, GDP, there's life expectancy. There's a lot of interesting questions you can dig into, but it also can be a metaphor for some of the data that you use because you can think about it in terms of study sites and repeated sampling and different indicators. Anyway, so that's just a preview of where we're going to go. By the end of all of this, we're going to have wrangled and worked with this Gapminder data. We're going to make our own graphics, build a web page, and publish it. So there's a lot of both analysis and communication and collaboration that we're going to do throughout this whole series. These are kind of prerequisites to starting the course, but we can make sure that we've got this all done together. Do you guys have current versions of R and RStudio set up? This book is built off the backs of so many other awesome training books that are available online and training materials. So you can get into way more detail in Hadley Wickham's R for Data Science and Jenny Bryan's materials that she's worked a lot on, and software carpentry stuff. So there's tons of other resources out there, and this borrowing directly or building off of what other people have done previously. In this RStudio and R Markdown chapter 3, we're going to get oriented to the RStudio interface and talk about why we use RStudio instead of just R. We're going to work with R in the console, be introduced to built-in R functions, learn to use the help pages, explore R Markdown, and then we're going to get configured on our computers. If R were an airplane, you're the pilot and you can take your airplane wherever you need to go, and you'll become a better pilot and you'll be able to go further places, right, with your research and with your data analysis questions. And I think of RStudio as an airport, or like a network of airports even, because it gives you a place to land, it gives you communication support, it gives you community, it gives you support. So you can code without RStudio, but we just find it so useful and helpful and have to have everything in one place. So we really encourage people to use RStudio instead of just R. When you're learning to code, you're learning a new language. It's an ongoing process and it'll be frustrating and you'll make mistakes and you won't be understood, but it's all part of the process. And also, even if you're fluent in a language, you're always learning different idioms, different contexts. There's always more to learn. So something that's an additional challenge with learning a programming language is that you need to sort of think about having different expectations. But when you're learning to program, you don't really have those expectations. You might expect that there's a way to calculate a mean or a median, but you might not expect that there's a way to transform your columns into rows, or search for patterns within text, or sort things numerically or reverse alphabetically. So there's kind of this additional expectation that we're going to try to teach you, so that you expect that there's a way to do something and then figure out a name for what that might be so that you can search for it and figure out how to do it. So it's like this added context that we're going to try to help you think about. If we open up RStudio, and I switch now to my RStudio sessions, the first things I like to point out when we're in RStudio is that there's these 3 default panes. This is R. This is the R console. So if you were working just in R, this is what you would have, just this single pane. And then on the right side, we've got this pane that right now is the environment pane, but you can see there's also additional tabs up here that are history and some other things. We'll look at that more in detail later. And then there's also this pane here of, right now it's your file history. So this is what I would be looking at if I were in my Mac Finder or on Windows Explorer. This is the same kind of file structure. And then there's other tabs here that are plots, packages, help viewer. We'll explore that in a bit. The first thing I always do when I open up a new RStudio session or R session is to think about where you are. If you've just opened RStudio for the first time, you'll likely be in your home directory. And this, you can tell that you're in your home directory by this symbol here. This is showing you where you are. And this little tilde or twiddle here represents your home directory. So for me, that's Julia Lowndes. It's for you, it would be whatever your name is or whatever your sort of computer's name is. So this little symbol here represents your home directory. And you can also see that when you are home, when you open a new session, this file viewer defaults to also that home. But you can also see that as you click through things, it will change where you're navigating, but it won't change where you are. And I guess that's kind of a familiar concept where, like, if you're saving a Word document, you can choose to save it somewhere else than where you might think that you are. Let's start doing something in R first. So in R, you set variables by using an assignment operator. So we can do some math in R like this. So you can see what I did was I created an object called X, and I assigned that X to be 3 times 3. And you can see then, if I ask what X is, it will return a value of 9. You can also see that in my environment pane, this showed up here. This object now has a value of 9. So in my head, when I write this, I hear X gets 3 times 3. And so the way R works is that something like an object name gets a value. And this is just a little note to myself. This won't actually execute. So if I put a hashtag in front of it, R will know that this is a comment that it's not going to try to execute or do any kind of operations on. So objects can be called anything. You can assign objects with any kind of name, although there are some rules about not starting them with a digit or some other strange, like you can't start something with a $sign or something like that. But there's a lot of different ways you can name objects. Calling something X is not very descriptive, but you could call something using snake case. That's what this is called. So you could assign something to be 3 or 4. You could also use periods. Other people use periods to assign. And then even other people use camel case. So you can see that there's different conventions and there's different value. Depending on what you're assigning, you could be very clear in what it is at the cost of having it be a very long name, or you could have it very short at the cost of having it be really ambiguous. But there's different ways of assigning them, different variables here. If I wanted to inspect what other people use periods is, I could either type it out, and actually RStudio will predict what I might be asking for, which is really nice. And then I can press tab and complete it before hitting return. Something else I can do is use the arrow keys to go back in time through each thing in my history. Yeah, so there's a couple different ways to do that, and then I can come back to the present by pressing the down key. If I'm using the up keys to go up, I can also hit escape at any point to clear my console there. When we were talking about error messages, Googling the error message, if we try to look into that, let's say our anything variable, and let's say we have a typo in there, so it will give me an error. And something that, I said this before with that Googling the error message book cover is like error messages can actually help you learn and they can be your friend. So even though it seems scary to see a red error message, oftentimes it will help you figure out what the problem is. So it's not just saying it doesn't work, it's saying this is incorrect and that's why there's a problem. So when I see this object, anything not found, that immediately draws me to exactly what I had done wrong. And then I can see that I have a typo. There is no variable with these two G's there. I use a ton of RStudio shortcuts. Like I showed you, this up and down arrow key is one of the shortcuts I use, but you probably also saw that when typing out this arrow key, you can do it with the side arrow and the minus key, but there's also a keyboard shortcut, which is Option minus key if you're in RStudio, and then just pressing a key over and over and over. That's how you can have this shortcut there. So this is Option minus on a Mac. Gives you this nice, quick assignment operator. Okay, and then if you're not on a Mac, or if you want to know other keyboard shortcuts, there's a lot of options up here at the top of your RStudio session. And if you ever go to the help, there's a whole keyboard shortcuts help up from the help file. And if you click on that, you'll get this overlay of all of the keyboard shortcuts, more than you could ever imagine you need. But it's amazing how once you get into coding more and more, you'll see that the reason people thought of these keyboard shortcuts was because they are operations that are done often. So the way you went to this was to go up to the help file. And there's a lot of great things in this help file. We'll keep coming back here to explore it. But right now, to go to the keyboard shortcuts, you go here to the keyboard shortcuts help. And you can also see that there is a keyboard shortcut to make the keyboard shortcuts come up. So you can play around with that too if you want. But this will also help if you're on Windows. It will be specific to Windows. And this is insert assignment operator is how we did Option minus right here. So let's go back to the R console here. I'm just going to press return a couple times just to give a little space here. Actually, I'll move back to the training book just for a minute. Okay, so when we're talking about things you can do in R, there's a lot of questions you can ask about the objects as well. Instead of just assigning them, you can also ask if something is equal to, is not equal to, is less than, is greater than, is less than or equal to, is greater than or equal to. So these are some operators that you'll see throughout code, and it will help you ask questions as you go through. So what we can do is if we go back to our code, let's ask a question about our variable called anything. So we can say, is anything equal to 2? It will return an answer to our question, and it says it's false. Anything is not equal to 2. We can ask another question. We can say, is anything greater than or equal to 30? And see that it's also false. We can see if anything is not equal to 4, and then we can get a true back. This is just a simple example, but you can see that if you had a lot of data you were trying to sort or pull out in some way, that you could start asking questions about it. One other thing I want to say about this assignment operator is that you can also assign variables with an equal sign, and it will be assigned just the way we had done it with this arrow symbol. But it's better practice to use this arrow symbol, and because there will be equals that will come up in other places in our code, and so it's better to be really distinct when you're assigning a new variable. So this is something I have just started to do. I learned how to code using this equals operator, and I was kind of skeptical about the benefits of changing my behavior, but now I'm totally sold that this makes it a lot clearer. So in the Ocean Health Index, we're moving to redo all of our code with this operator. Let's do a little example here where we have a variable called weight, kg, so weight in kilograms. We assign it to a value, so let's give it 55. So if we have weight kilogram gets 55, we can inspect to make sure that this weight underscore kilogram object is what we think it is. So again, we can type it in and have RStudio help us autocomplete it. Something else I like to do sometimes too is if I press the up key and get the entire thing back, I can delete the assignment and then hit return. So just to inspect what this weight underscore kilogram is. Now that R has this weight kilogram variable in memory, we can do arithmetic to it. We can do things to it. So for instance, we might want to convert this into pounds instead of kilograms. If we convert it by 2 times 2 and then multiplied by weight kilogram, we'll actually get a numeric value back. Because remember, weight kilogram is not English. It's a variable that's getting the value of 55. So you're able to multiply 2.2 times the value that weight kilogram gets right now. So if we multiply 2.2 times weight kilogram, we'll get 121 back. We can also change the value of one of these variables by assigning it a new one. So if we want weight kilogram now to equal, let's say 57.5, now if we multiply that by 2.2, which is exactly what we've done previously, we'll get a different value here at 126.5 because this weight underscore kilogram has been assigned a new value. And so the arithmetic will give a new value. Great, so we can actually assign this example to a new variable itself. So we could say we want this to be in a variable called weight underscore in pounds. LB is strangely shortened words for pounds. But if we want this variable to be called weight underscore LB, and that gets our arithmetic here, 2.2 times weight kg. If we assign that, then we'll have this new variable called weight LB that we can inspect. And as we expected, it is equal to the arithmetic that we had just tested above. Okay, so what's cool then is let's again change how much the original kilograms were. If we change what the original kilograms were to be 100, what do you guys expect this weight in pounds to be? Weight LB will still be 126.5 actually, because weight in pounds has still been assigned the value back when weight kilogram was 57.5. So this is a really important concept here, is that when you have variables that rely on other variables, you need to update all of the variables if you want them to be what you expect. So in our case, what we need to do is, if we wanted weight LB to reflect this new weight in kilograms that is 100, we would have to rerun this assignment where we assign weight LB to again be 2.2 times weight underscore kg, which has been updated. If we rerun that, then we will get it to be 220. This is something that we'll keep coming back to, because as you develop analyses that are more and more complex, keeping track of that, of what your variables are, is important. And that's why we'll move away from working just in the console here and into working in scripts. We'll get there soon. I'm going to come back to the materials here for another minute. So R has a ton of built-in functions that will let you do more complex operations as you go along. So functions all have the same syntax so that you're able to do what you want to do as quickly as possible in most cases. So the way this syntax is that there will be the name of a function, like maybe it would be mean or median, and then there would be arguments you pass to it. So there would be an argument that gets a value when you call this function. So let's go back to R. And we're going to use a function called seq. As I start typing, RStudio, again, it's anticipating what I'm going to do. And something that's important here then to notice is that when you do assign your own variable names, this pop-up can help you make sure that you're not naming your variable something that already exists that might cause confusion. Okay, so this seq function will make regular sequences of numbers. I'm going to use this seq function. I'm going to give it arguments 1 and 10. So you guys could probably guess or infer that this seq function is going to make a sequence of the arguments that you have given it, right? So the seq function will make a sequence from 1 to 10. So that's great, but let's actually learn more about what it could do. Every function will have a help page that will help you understand what's going on. So the way to find the help page, there's a couple different ways, and I'll show you several different ways, is you can press the question mark sign and then the function name. You'll see too, RStudio is going to pop up with some information about what seq does. So you can see it generates regular sequences. Then it tells you more information that to me doesn't mean much now. So I want to go to the help page. You can see that it's also saying that you can press F1 for additional help. I'm just going to hit return with my question mark seq, and it's going to pop up the help tab over here. So the help pages are where I spend a lot of time, and I think you all will as well as you move along. So I'm going to show you kind of the overarching structure of help pages, and then we'll actually learn about sequence itself. But the way all the help pages looks is it will tell you what the function name is, what package it's in. We'll talk about packages a little later. It's where to find this function. It will then tell you the name of the function here, a description, and usage. We'll walk through all of this in a second. It will tell you some arguments, more details than you probably need, typical uses, maybe, a lot more information, references, and then examples. So examples are often really useful. We'll come back here in a second and try these, but this is when you open a help page, you can expect to find a lot of this information. This description is what popped up for us over here when we were over there. It says it generates regular sequences, and then we can understand that. That goes from 1 to 10 like we expected. And then it gives more information than I personally understand right now or is useful for what I'm looking for. So I read this, and then I continue down to see a little bit of the usage. We use the seq function. You can see sometimes there's sort of cousin functions that are sister functions that are available as well, but we use the seq function, and you can see that the first argument is where you want to start from, and the second argument is where you want to go to. So back over here, when we said seq 1, 10, what we were doing was writing a shorthand of from equals 1 to equals 10. And this gives the exact same output. So what R is doing is if you don't name the actual arguments, it will resolve by the order that you put them in and interpret what you mean in this convention that ordering matters. So even when I didn't say from equals 1 and 2 equals 10, it understood that. But you can see that there's a lot of arguments that are in this function that are being defaulted, that R is interpreting by default. Let's explore what this means. What if we tried the by function? So I'm going to press the up key here. If I add another argument where I say by equals 2, you can see that it's going to change the steps that were involved here. The way I usually work is if I were going to create this sequence, I might write it like this, where I say from 1 to 10 by 2, because usually sort of the first 2 arguments that you set are the closest ones that are in your mind. But if there's extra arguments, you might label them. But it's all convention and it's all up to you. This will return the same information. So there's a lot of other things to play around with in here. What I like to do to understand a new function is I like to, after reading more about the arguments and seeing kind of, this says from and to is the starting and end values of the sequence. Length 1 is used unless supplied otherwise. This by is an increment of the sequence. Length out is the desired length. I like to scroll down to the bottom and see if there are examples here that I can run. And so these examples, you can actually copy them and paste them into your console and run them. So if we wanted to know what this length out variable means, you can test it. Sometimes for me, reading about it is not always as effective as testing it and seeing what's going on. So it seems that this length out variable will parse this sequence into, in this case, 11 unique instances. So it will sort of step it out for you. Something that's cool that I think is possible in RStudio now is if I can actually execute this example directly to the console, which is kind of cool. We can get into this more later, but instead of copying and pasting this, I can press Command Return, but copying and pasting it works perfectly well as well. And you can either type these into the console with a question mark in that help window itself. You can also search a question like plot.
Type in your console methods parentheses plot. It tells you, I think, all of the potential objects that could be plotted, like data frame, factor, formula.
What does the trim option do? There's an example here, we could try it. Okay, if we say that X is these numbers, and then if we say XM equals mean of X, 8.75, and then if we look at these things together, mean of X trim. Say X is this sequence. This is something that's cool. If you put parentheses around the assignment, it will print it for you. So I don't have to call X separately. So right now we've got X is 0. It's essentially the sequence 1 through 10 with a 0 and a 50 on the ends. So if I take the mean of X, you know, it's higher than you might expect because this 50 is really pulling it up there. But if you want to trim off 0.10 of your values from either end, so it's kind of trying to get rid of outliers if it's ordered properly. So there could be circumstances where this wouldn't work, but this is just a tool that's available. If you say mean of X trim, you'll get this variable 5.5, and then we were trying to understand what that actually means, what's actually going on. So we tried by saying, like, let's call this X2 is just a sequence from 1 to 10. It doesn't have the 0 or the 50 at the ends of it, so it's only 1 through 10. And now if we take the mean of X2, it explains it was trimming off the 50 and the 0. So trim is the fraction of observations to be trimmed from each end. So you'd have to know that you wanted to remove 0.1 observations. You kind of have to have done the math ahead of time to know how long your sample size was and how much you want to trim. I can imagine more ways than you wouldn't want to use this than you would, just because I think you'd want to be way more in control of what it's trimming and like how you're dealing with outliers. But somebody built this because there was a need at one time to do that. So it's just kind of interesting to see like what options are available and whether they'd be useful for you. Get WD means returning the absolute path of where you are. So if we type that in, for me, it's users Julie Lowndes, and this is what is represented by this little tilde or twiddle thing. Let's keep going here. Sometimes searching within the help functions over here in this help pane is a really good way to get up these help functions. Using one question mark is also good. But sometimes you don't know what a specific function is actually named. You might have an idea, but you might not know what it's actually called. So you can also use a double question mark. So if I say double question mark of install, in the help results, it will show me all help pages with some kind of install thing associated with it. So you can see that there's many different options that you might want here. So the way I look at this is we haven't talked about packages specifically, but they are represented in this list in front of the double colon. So this is saying that there's a warn current version function that is within this Arctic data utils package, or there's these things within the DevTools package. And since we don't know what those are, I'm going to be scrolling down here looking to see if there's some kind of base R function about install that we might want. So I don't want anything with GitHub. I don't want anything with any of these things. But if I and you guys might not have these many because these are artifacts of other things I've done in the past that I've installed. So if we roll all the way down, there should be in this kind of utils is something that R comes with pre-installed. And so you can see that there's a couple different ways to install packages, check for what packages are installed, remove packages, update packages. But I'm saying, is there a function that has something to do with a min? Is there, and then it's like, oh my gosh, there are a lot. Okay, maybe I need to do some Googling. Maybe I need to refine my question. Like, is there a double question mark for get WD? Let's see. And it's like, oh my gosh, there's a lot more options than, I don't know how, this is not helpful to me right now. But what could be helpful for me is if I knew I wanted to install something, I didn't know the name of it yet. So this can be useful sometimes though. Like Google might be my first place to look, but if you don't have internet, this will let you search for what you have already on your computer. Something else to mention just when we're exploring right now is that not all functions need an argument. We've just seen this with get WD. We didn't actually put anything in between those parentheses. We didn't pass it an argument. And if I look at get WD, you can see that the default is that there's nothing that you pass to it. You can see that it will return your file path, I guess. A better example is there's a function called date, and you don't need to pass anything to it, but it will give you the immediate current date and time. So if we looked at what date does and returns, you can see that when I ask for something, I didn't meant to type date, but I mistyped here. And you can see that it says there's no packages. What do you could try seeing if there's something called dated. But if I actually do $date and type it correctly, it doesn't actually take any arguments. It will just tell you what time it is, what date it is now. So I don't know about you guys, but I have a lot of stuff here in my environment. I've got everything that I assigned is over here. You can look at it all in one glance here. There's also a way to inspect it from the console. You can say objects. And if you hit return, you'll get a list back of everything, all the objects you have there. So you might have different ones than I do. Sometimes there's different ways to achieve the same thing, just like in any language. So there's also a function called ls that will return the same thing. It's a short case for list, I believe. It will list everything that's there. Let's say you want to remove an object. You want to get rid of x2. Let's say we just don't need that anymore. You can remove it using the rm function, and you can say rm x2. I saw it immediately disappear from my environment. And you can confirm that by, again, calling ls. And you can see that it's not there anymore. If you wanted to remove everything, there's a couple different ways to do it. You can say rm, and then you have to pass in an argument called list equals ls. Okay, so to break this down a little bit, so when we call ls, it returns the names of all of our variables, and we can use that to remove all of it. So we don't have to even assign this to a variable. We can actually put a function within this other function remove. So you see that rm is a function, it will remove something, and ls is a function that will list all the things. So you can use them together. You can say remove whatever is returned when you list all of the things. So if I press return here, it's going to remove everything that was listed here. This is pretty powerful. And why can't we say rm ls parentheses, like under the assumption that it knows its lists? And the reason is because the first argument is actually not list. The first argument, you could pass it something else. So it can't work on default ordering like we were talking about before. What this ... represents is it means that you could pass it something else first. So when you actually want to list something, you need to be explicit about the list. Something though that, let me put another x variable in here. Something I do more often, though, is that RStudio has ways to do the same things that you could do from the console. There's this little broom object here, and you can see when I hover over it, it says clear objects from the workspace. So if I press broom, it's going to say, are you sure you want to remove all your objects? And I'll say yes. And then it will clear it up as well. So clearing up your objects as you go is an important part of reproducible research, because if you are working on something that you have locally that might not be something you've explicitly set up, it can cause problems later. So one of the things that we do a lot as we work is to clear our whole environment and also to reset our whole R session so that you're starting with a clear slate, so that when you begin to run an analyses again, you can be sure that there's no kind of extra artifacts that you don't expect. So the way I do that is I like to press this little broom icon up in the environment. And then also I go up to the session panel up here and I restart R. And I do this a couple times a day when I'm coding analyses to just restart. So like you go to lunch, you come back and just you clear it again and just make sure that there's no artifacts as you continue moving forward.